All right, P3, we are getting there. Remember, we test over P1 to P5 next Friday. So we'll be 2 days of P3, which is radicals and rational exponents. And then we'll talk about polynomials on Friday. And then, forgot what P5 is. But polynomials will be Friday, and we'll kind of go from there. So whenever you have a product rule with radicals, it works the same way, okay, as what it was with exponents. So whenever we multiplied exponents, what did we do? What did we do with our exponents? If we had exponents and we multiplied, what did we end up doing? We added them, right? If we divided, what did we do? We subtracted. Okay, so here, whenever we deal with a product rule, basically what's going to happen is it's going to look something, it's really not a definition, it's more, I guess, the example, is that if we have the square root of AB, we can basically just write it out as the square root of A times the square root of B. It works both ways. Okay, so we can, if it's two things multiplied together, basically we can factor everything out. Okay, if the reverse side of that is really just if we have the square root of A times the square root of B, and we can combine anything together. The quotient rule is really, same idea, is that if you have anything underneath a radical, like C over D, I can basically just split it up to where I have the square root of C over the square root of D, and vice versa. If I start with the square root of C over the square root of D, I can put everything underneath the radical, and it works in both directions. So whenever we deal with the sum and the difference of radicals, you have to have the same parts underneath the radicals. Okay? So the radicands, the part underneath the radical, okay, must match if you add or subtract. You all are accustomed to basically being able, like if we have 4x plus 6y, can we add those two together? No, why not? They don't have the same variable, right? It works the same way with a radical. If you're going to have the square root of 2, if you want to add or subtract, you better have the square root of 2 back here. Okay? So, like 4 times the square root of 3 plus 10 times square root of 3. You treat it just like you would a variable. Okay? So, if you have the square root of 3, if you had a 4x plus 10x, what would you do? 14x, right? So in this case, we're just going to add the number, the coefficient, or the part in front. So 14 times the square root of 3. We're just adding the 10 and the 4. The radical stays the same. Now, product rule, remember whenever you have a product rule, you're trying to separate everything out. So like if I have the square root of 500, what is a perfect square that I can break 500 into? Like what's the biggest perfect square that I can divide into 500 evenly?
25?
Bigger than 25?
100?
100. So I'm going to break it up as the square root of 100 times the square root of 5. So what's the square root of 100? 10. So 10 times the square root of 5. The bigger the better. Okay? If you had me in class, you know whenever we had everything listed, we always started basically at the bottom and worked our way up to, like we started with the bigger numbers and worked our way up to the smaller numbers. Whereas here, everything's split up. So you've kind of got a few options. Before, if you would have been given the square root of 6x times the square root of 3x, what would your previous instructor have told you to do? Would they have had you put it together, or would they have you just break everything up? So, if I have the square root of 18x squared, right? 6 times 3 is 18, x times x is x squared. Now I want to individually look at each part. So I'm going to look at the square root of 18, and I'm going to look at, bless you, the square root of x squared. How can I break up? What's a perfect square that I can break up or I can factor out of 18? 9, right? So this is the square root of 9 times the square root of 2. What's the square root of x squared? Just x, right? Square root of 9 is 3. So I have 3 times the square root of 2 times x. Everything that's left outside of the radical goes in front. So 3x. Everything that's left inside, square root of 2. If we do 6, we have the square root of 5 minus 7 times the square root, or excuse me, square root of 5x minus 7 times the square root of 5x. Now, biggest thing that happens is we've got to make sure that we pay attention. What number is right out here?
1.
1. Okay, so just because you don't see a number, there's still a 1 there. So is everything underneath my radical the same? Do I need to simplify it to where they need to match? Or do they already match? They already match, right? So they already match. So I have the square root of 5 and I have the square root of 5. So then it's real simple. What's 1 minus 7?
Negative 6.
-6. So I have -6 times the square root of 5x. Now, in 7 and 8's case, do I have the part, do the radicals match? No. Okay, so I'm going to have to simplify them before I can do anything. Okay, so like the square root of 3, is it simplified as much as possible? Yeah. What about the square root of 12? If I'm going to basically go over here kind of off to the side, what's another way, or how can the square root of 12 simplify? 4 and 3, right? I'll give you a hint. They're going to give you, most likely, they're going to give you a value that you probably want to try, especially if there's one that you don't have to fiddle with, or you don't have to simplify. Okay, that 3 is a good hint that, hey, I can probably divide this number by 3, which I can, which is the square root of 4 times the square root of 3. So what is the square root of 4? 2. So really all I'm going to do is I'm going to rewrite the square root of 12 as 2 times the square root of 3. So really all this problem is 7 square root of 3 plus 2 square root of 3. So now do my radicals match? Yes? So what's my final answer? 9 square root of 3. Hey, neither of the two are completely simplified, so I'm going to basically go the square root of 50x. So how can I simplify the square root of 50x? What's a perfect square that I can divide by 50? 25. So I have square root of 25. I have the square root of 2. And I still have the square root of x. Okay? It's still underneath there. What is the square root of 5? Or 25? Just told you. So I have 5 square root of 2x. So all I'm going to do is replace the square root of 50x with 5 times the square root of 2. So I have 4 times 5 square root of 2x. Now we'll get to that in a second. I need to do the same thing over here with the 32, or the square root of 32x. So if I have the square root of 32x, again, look at the problem. Look at what we ended up with. What's most likely going to be a number that's going to be left underneath the radical? 2, right? So what is 32 divided by 2? 16. Is 16 a perfect square? I'll be. You believe they did that? So what's the square root of 16? 4. So I have 4 times the square root of 2x. Again, now I'm going to take this 32x, or the square root of 32x, and I'm going to rewrite it as minus 6 times 4 times the square root of 2x. Now, I'm not completely finished here. Okay? What do I need to do with the 4 and the 5? What's getting done with the 4 and the 5? Multiply. So really I have, oh, you can't see that. That's not a good color. Let's try again. So 20 times the square root of 2x minus 24 times the square root of 2x. Now can we combine or add or subtract? You bet. Negative 4 square root of 2x. Happy clouds, happy trees. Assignment for today is 45 through 46. You're going to do 1 to 13 odd and then 35 to 43 odd. So it's pretty short.